Now let's find the area between two z-values. So I'm going to go ahead and draw my picture. I'm going to label, remember, 0's at the middle for the mean. Our mean is 0. Then I'm going to go ahead and label, they're both positive. Z equals 1.56 will be closer to 0 than z equals 1.96. So if we go to our table, table E, and we look up z is 1.56. Let me zoom in a little bit here. So here's 1.5. Now I need 1.56. So we get 0.9406. And while I'm on the screen, I'm going to go ahead and also look up z is 1.96. So here's the 1.9 piece. I have to follow it over till the 6 piece. So when z equals 1.96, we have an area of 0.9750. I'm going to go ahead and switch back. Now remember, the areas that we're looking at are to the left. So we had 0.9406. Keeping in mind, we never round these values. They've already been rounded. So z equals 0.9406. That is everything to the left of z equals 1.56. That's everything to the left. Then if we have z equals 1.96, when we look at that area of 0.9750, that's everything to the left of 1.96. So now the piece that we want, and I forgot to highlight this before we started here, it's that in-between piece. So in order to get that piece between them, I have to take their two areas and I have to subtract them. So I know the piece that's in all blue. I want to subtract out that yellow piece that I highlighted. So the area in between is going to be, let's see what we got there, 0.9750, 0.906, 0.0344 is going to be this area in between them. So go ahead and take a pause here and see what you come up with for the next one, where we have z is 1.10 and negative 1.80. So go ahead, take a minute and pause here. What you should come up with, your area should be 0.8284. If you weren't able to get that, please raise your hand and have me help you with that. So we have looked at finding the area to the left of a z-value, finding the area to the right of a z-value, and finding the area between two z-values. If they're on the same side of the mean, or if they're on opposite sides of the mean, our process still remains the same. Now you might also be asked to find the probability using the standard normal distribution. You will see notation that looks like this. All you're doing is finding the area between 0 and 1.69. So all you're doing, don't let the probability notation throw you off. You are simply just finding the area between those two z-values. That's all you're being asked to do. So if we were to do that piece, just trying to save you a little bit of time here, just a little general rundown. This is the same process we had before. If we want to find the area between those two, find both areas in table E and subtract. Now this is what it would look like if you're trying to find the area between two values. You might also see if you have just a greater than or just a less than a value. So if z is greater than, it's negative 1.39, so it would be over here on the left. And we want greater than, we want z to be greater than that, so we would shade the area to the right. That's what we're looking for. So in order to find that area, just a refresher on the process that we had just gone through, find the area in table E and subtract from 1. And remember, we do have that process table that you are always more than welcome to look at. That procedure table on page 316 and 317 in your book, you're more than welcome to use that as well. I know I really feel like it helps to draw the picture out. I really feel like that helps a lot. So don't let the probability notation throw you off. You're doing the same thing as if I were to just simply ask you to find the area. Because remember, these areas in here can also represent percents. They represent probabilities also. So finding that area is the same thing. Now the other piece that we need to be able to do is work our way backwards. What if we have a specific percent, a specific proportion, or a specific area that we have, and we want to find the z value that matches up with it? Now this comes to you from page 323 in your book. I did just copy and paste it from there. So let's take a look at what we're trying to find. We know the area. We know the area. We're trying to find the z that matches it. So what we want to try to find, we know the area. Now the table that we have, our table E, will tell us the entire area to the left of a z value. So we need to take the area we know and we need to add a half onto it. I can't just look at the table and find this little area in there and match it with the z value. I need to also add a half on because the table will give me the entire area to the left of a z, not just the little chunk that we're looking for. So we're going to have 0.4066, add a half onto it, add a half onto it, and now this is the area, to the left of the z value that we're looking for. Now if we switch and go to table E, table E is full of areas. Z values are out here in these columns. These are z values out here. What we find in the body of the table are all areas to the left of z values. So we need to work our way backwards. I know the area. I need to work backwards and find the z. So I need to scan through this table and I need to find an area as close as I can to 0.9066. I know I want to be on the right side of the table because my z value is on the right side of the mean. So if we look in the table, we want to try to find as close to 0.9066 as we can. And you just have to kind of scan through. You start at the top. A lot of them are 0.5s, and you get into 0.6s, 0.7s, 0.8s. Now I'm starting to get into some 0.9s. And we happen to find it exact. You might not always find the exact one. If you can't find the exact one, you go with what is ever closest. So now I have to work my way out. This matches 1.32. Matches 1.32. So this z equals 1.32. So what we did is we looked up the area in the body of table E. So not in those outside columns, but in the actual body. That's where the areas are. We're working our way backwards from what we just did in all of our other examples. In all our other examples, we had Z, and we used Z. We used the side column in the top row. We found the Z we needed, and then we went to the body of the table to find the matching area. Now we know the area, so we're going to start in the middle in the body of that table and work our way out to that side column in that top row to find Z. Now I do want to show you for the assignment piece, I really did minimize the number of questions. So if there's any concept you feel you need more on, you can definitely do more of that section. The technology steps, I do want to go through just a couple of those with you. Please make sure you read the section, paying special attention to the distribution shapes discussed on these pages. And those distribution shapes we have seen before, so they should be somewhat familiar to you already. So I do want to go ahead here and show you some of the technology pieces. Now the first one, if we just want to find, for example, the area to the left of a z-value, we go second, distribute, and now we're looking at options 1 and 2. We're looking at the normal distribution. Remember, this is the same menu where we'd find Poisson and our binomial. So now we're working with the normal distribution with our continuous variables. And we always want to go CDF to find an area. Now my calculator is going to be a little bit different than maybe some of the older ones. If you have an older calculator, I can help you with that. You're just going to be entering things into parentheses if you have an older calculator. If you have an older calculator, you'll have normal CDF on your screen right now. For the lower ones, we need to tell it if we're going to go to the left of negative 2.12. That was one of the examples we had. If we want to go to the left of that, we need to tell the lower boundary of it to be negative infinity. So to do that, we need negative, and then we need the double E, which is second, and then the comma, and then 99. The upper value then is the z value that I have, negative 2.12. So if you want the area to the left of a z value, you have to tell the calculator that the far left value is infinity, and this is how we enter infinity into the calculator. Then the upper value where I want it to stop is my z value. Your mu and your sigma will always be 0 and 1. Those are properties of our standard normal distribution. So we do not change those. If you have one of the older calculators, you're just entering the lower, comma, the upper into your calculator. You don't have to worry about mu and sigma. So just lower, comma, upper in your calculator. paste it, enter, and there we go. We have the exact value that we had. If we want to find the area to the right of a z-value, second, distribute. Again, we always need normal CDF because we want that cumulative area between those z-values. Now, if I want the area to the right, let's use 1.75. That's the example we had. The lower then becomes 1.75. And then the upper is going to be positive infinity. So we need to go second, comma, for the double E. I know it shows a double E, then it's a single E on the screen, but that's what we need. And then 99. That's how the calculator signifies infinity. Oops, sorry guys. Here we go. And our mu should be 0 and sigma should be 1. So again, I want the area to the right. So my lower value is my z-value I'm interested in. My upper, I have to tell it infinity. If you have an older calculator, you don't need the 0, 1 on your screen. If you don't put it, the calculator just assumes 0 and 1. Otherwise, if you have an older calculator, you'll see normal CDF, parenthesis, 1.75, comma, the E99, and then close your parenthesis. You don't need the 0 and 1. You can put them if you want, but you don't have to. And there's the value we got for the area to the right of 1.75. If you want the area between, second, distribute, normal CDF, and let's just look at, we had 1.56 and 1.96. The lower is 1.56. Whatever your leftmost value is always your lower. Your rightmost value is your upper, 1.96. And then we paste it to our screen. And there's our value. Again, older calculators, you would have normal CDF, 1.56, comma, 1.96, and then just close your parenthesis there. You don't need the 0 and 1, that's okay. Now, if we want to go the other way, so what if I know the area, Miss Golly, and I want to know the z-value? We can go back, second, distribute, and we have the I and V norm, so the inverse of our normal distribution, so we're going the other way. Now, the area you need to enter in, if you're doing an older calculator, you always have to enter in the area that's to the left. If you have an older calculator, you always have to enter in the area to the left. So the area, if I look at our very last example, the area to the left of the z-value was 0.9066. The tail piece they're talking about is which way is shaded. Are we shaded left? Are you shaded in between? Are you shaded to the right? So for my purposes, so I'm staying on the same page with everybody's calculators, I'm going to go with the area to the left. If you have an older calculator, all you have to do is the inverse norm, 0.9066, and you close your parenthesis. You don't need the 0, you don't need the 1, you don't need the left. Then remember, we entered an area, so 1.32 is our z-value. Just a general rule of thumb for us, areas go to 4 decimal places. Z-values, we go to 2 with the nearest hundredths, just so we stay uniform across the board. Calculator stuff, take it or leave it. There are calculator steps in your textbook for you if you want. They are on page 324. If you need my help, if you have maybe an older calculator and you weren't quite sure what to do based on what I said here, or even if you have a newer one and you need some help, let me know what you need.